In this example, we're going to talk about three force members and their implication. Right, now note that the system on the left, A, has three forces. They each pass through a common point 0. Whereas in the second one, we have three forces. Two of them pass through, of course, a common point. The third one does not, is offset by some non-zero value, and it has and we'll call that D perpendicular. Okay. In the concurrent force system, it's possible for those three forces to have the right magnitudes so that we'd have equilibrium in the translational sense, and we get exactly the aesthetic equilibrium. For some moments about point 0, since in each and every one of those forces passes through that point, their respective perpendicular distances are all 0, so therefore identically we'll have rotational equilibrium as well. But in the non-concurrent force system situation with only three forces, although we can get the right magnitudes to have translational equilibrium, it'll turn out that F1 and F2, their perpendicular distances with respect to 0 are 0. However, F3, a non-zero force, but its perpendicular distance also being non-zero, there's no way for this whole thing to equal 0. This body, if it were to attempt to try to be like this, will spin. It is not in equilibrium. So the implication is that if I have a body that has only three forces applied to it, those three forces must be passing through a common point in order for static equilibrium to occur. Note that we can resolve each of these forces into orthogonal components, and then maybe you're tempted to say, well, now I got six forces on the body. No, and no. You can resolve these two into one single force, those two into one single force, those two into one single force at some sort of known angle for each one of them. They have a point of application, and the only way when this situation is set up where I have a body with only three forces that can be in static equilibrium is if the lines of actions of the three forces pass through a common point. Anything else will cause the body to rotate.